So, hello to everybody. If you hear me. Now,
Yes. Yes.
Thank you. Good day to everyone. And now we start this training to basic of Earth observation and remote sensing. Thank you for joining us. And I am Associate Professor Andrija Krtalić from the Faculty of Geodesy, University of Zagreb. And we can start, like I said, with this training. This is the training plan for today. I talk about Earth observation and remote sensing. It's basic stuff, and about electromagnetic spectrum. Tomorrow we go more deeper to the images, digital images, sensors and platforms from remote sensing. And on the Wednesday, we deal with some ugly stuff. It's pre-processing and processing of remote sensing images, and about application of remote sensing methods and how we teach and manage this part of the science in Croatia on our university, on our faculty. So if you all on your seats, we can go with the first stuff of our training. It's Earth observation. So what is the Earth's observation? Like this slide said, it's the acquiring of information about planet Earth, but not just a planet like a whole, because on planet we have some objects or phenomena which want to see more than others. So the Earth observation is the gathering of information about planet Earth, physical, chemical, and biological system via remote sensing. Remote sensing is just a box of tools, like I said, for the Earth observation. The Earth observation, not very new, but only in recent days, we have opportunities to get to the satellite images. Satellite images, it's a free one, like a Landsat or Copernicus one, and hyperspectral images. So of course, it's also the images which are also used much in these days, especially for forestry and agriculture. So when study about the Earth, we often use this term, Earth observation, like you see on this image. The satellites brings the sensors. It's sensors for gathering information about, like I said before, Earth's surface, but not every satellite created the pictures. Some create the pictures, some just measuring things like temperature or pressure in the atmosphere, and they use that information for weathercast. So Earth observation is used to monitor and assess the status of and change of the natural environment and the built environment. Like I said, so you all know about the lava problem in Spain, or the floods or forest fire. It's everything, every dead thing someone can monitoring and get information from the images, satellite or aerial images, whatever. But the Earth observation is used to monitor and assess the status, like I said, and changes about Earth's surface and objects and the phenomena on it. I said all this like picture said, it's picturing from the satellite. you can imagine that the Earth do the selfie of herself, because we live on the Earth, we produce the satellites and put them in the orbit to gathering the information about our environment. And the first years, or in the middle, in the beginning of the Earth's race, the people look from the Earth to the universe. But nowadays we also still look to the universe and to gather knowledge about them. But according to satellites, we learn about our Earth also, and everyday things we gather from the satellite or for IRL sensors, we can put together, do the fusion, and have a better picture of our world, of our surface on the Earth. So we can provide a unique and timely source of data that is consumable across countries, regions, and cities. So the Earth observation data is unique source of all kind of information we have consumed about our environment and about Earth. And like I said before, it can be combined with other georeference, social, demographic, economic, and public administration data to make indicators and analysis more relevant and targeted. So you need, or you can put in your mind this word indicator, because the indicator is the key word for remote sensing. Because some phenomena, like I said, you can see on the surface of Earth, like chlorophyll, but with some indicators or some processing of images, we can see something which are put away from our eyes. I can put just like that. So it also can help harmonize international reporting and natural resources, ecosystem, and environmental things. So all this information about all natural goods, like we say, forest, waters, whatever you use in your countries, all information about that stuff from the universe or from the air can help us to better manage with these resources and to get better results from this from these fields. So the Earth's observation, it can be applicable, or application of Earth observation. It's like forecast weather, like you see on this image. And like I said before, some satellites gathering information from the atmosphere, like a density of the atmosphere, temperature, pressure, whatever weathercast people need to do, they preposition for the weather for the next time. Like, you know, in the United States, it's also, or wherever the hurricanes became, it's very important. It's for human health and life to know where and modulate where this eye or where this hurricane go, to alarm people, to hide yourself or whatever they do in that times. Second, it's tracking biodiversity and wildlife. So with this stuff, or with the drones, or better maybe with drones or satellite, or with some sensors on the Earth, someone can tracking or I say can looking on the wildlife or the natural goods, like I said, and can do the classification of some natural goods and get the information from this side of remote sensing from methods about some fields and common state in that fields. Measuring land use change, so like deforestation, like you see on this image, you can gather images from the one period of time, so today or 2 months after or half year after, 2 years after, and after classification or some automatic processing, analyze the surface, what the surface be 2 years ago and nowadays, and according to these differences, someone can get the information about differences in these 2 times on some specific spaces. Monitoring and responding to disasters like a flood or tsunamis, so or earthquake like we have in Croatia last year in 2 times, so or meaning energy sources, fresh water supplies and agriculture, addressing emerging disease and other health risks like COVID, but according to COVID, we need to stress some, like I said, indicator, and through the images, we can monitoring some maybe urban places, because if you have lockdown, nobody can go out from her places, and the density of the population on the open space, it's less, it's minor than in the days without some disease. Or predicting came after the collecting of the old source information. So all this can be application of Earth observation. And how someone can reach to the results, like you see on these slides, it's through the remote sensing methods. Like I said before, the remote sensing is a toolbox of methods for gathering application for Earth observation. So, like I said, this definition, remote sensing is techniques of observing and analyzing objects from a distance without being in direct contact with them. What does that mean? The real remote sensing now we have on the Mars. So we put some robots on the wheels on the Mars, and they collecting the images and some samples. We cannot say Earth samples, but samples of soil on Mars, and that information came to Earth. And according to these pictures and analyzing of that soil, the experts on the Earth gather that's information and can get some perspective about this planet. So that's the real remote sensing. But today's I personally want to know are my results or in accordance to the real information which could I get from the ground or in situ data. So today's, I think it's very important to have information from the ground. So if someone want to produce the land surface temperature from the radar images, they can. But how this is compatible with the real data? That's the real issue. Because we all want to know are this satellite data or remote sensing data are good for the everyday use. So it's the old version, it's the direct contact. It's okay because when the satellite collect the image, they don't have direct contact with the Earth's surface. But if you know when the satellite go through the orbit behind your place, your surface of interest, that day someone can go to the field and measure some data which will be comparable with the satellite data. So I want to stress that's the importance to have the in situ, and that's called the true data. It's a true data about the stuff or object or phenomena on the Earth. And after that, you collected or someone collect the information from the satellite. Why? Because if you see the connection, if the connection are in this field, you can easily use that kind of mind of information on whole picture, on whole image, and in the other image in that pass through the orbit. So you don't know, you don't need to once again analyze or question the ones analyze the information about the same surface in the accordingly same times. So strict definition, from the International Society of Photogrammetry Remote Sensing, which is the RUF Society for Remote Sensing and Photogrammetry. This definition valid from the 2016. So remote sensing is the science and technology of capturing, processing, and analyzing imagery in conjunction with other physical data of the Earth and the planets from sensors in space, in the air, and on the ground. So all three components are here: capturing, so they deal with the sensors, processing, deal with the images, and analysis. And we deal analysis after preprocessing, processing, or whatever you want to do or need to do with the images. Why it's valid from the 2016? Because before 2016, remote sensing and photogrammetry are used the same definition. And when the remote sensing grow up, like I said, and the pixel of the satellite image go small, they go apart. Why? Because of that definition of the photogrammetry from the 2060s. Photogrammetry is the science and technology of extracting reliable three-dimensional geometric and thematic information, often over time, of objects and the scenes from image and range data. Why I bold this reliable three-information dimensional geometric? Because the photogrammetry need to get the results for the cartography. or whatever they use for the measuring. Every map or situation have a scale, and every object in that scale need to be measurable. And objects in environments and interaction and with objects or distinguish with objects need to be measured. So the photogrammetry, it's more exact science than remote sensing. Photogrammetry equal geometry because they have the rule in photogrammetry and they need to satisfy that rule, and that's precision, that's accuracy. And in remote sensing, how could you be accurate with the pixel of 13 meters, 30 by 30 meters? It's a 900 square meters pixel, and everything what can be see on the Earth in the surface on the 900 square meters. It's a car, it's a human, it's a building, road, whatever. Every that information get just one number with just one value of pixel value. So that is the real distinction because between photogrammetry and remote sensing. Before 2016, the remote sensing was just a part of the photogrammetry. And nowadays, I can say that can be other way around, because remote sensing, it's more usable for the cartography. And photogrammetry is accurate one, but you need, or someone need more time and money to get that precise information, because you need a lot of images and someone need to produce the models and need to gather information from the models, and from the remote sensing satellite images, it's bigger swaps, and much more information can get from just one image. So photogrammetry equal geometry, it's most accurate, and when you need to do some accurate business, you need to produce the photogrammetry mission and the photogrammetry measured, photogrammetry survey. No questions about that. But if the accuracy is not so mandatory, remote sensing is the science who you can use to gather the information about the Earth's surface. Remote sensing is radiometry mostly, and the photogrammetry it's geometry and accuracy. So what's the task of that remote sensing? It's developing a mission and design spectral spacecraft and instruments. Like I said before, it's one task of remote sensing. It's the design of the platforms and the sensors to operate within the constraints of that mission and to characterize a target remote from the investigator. So some experts in electronic engineers and other people who deal with this kind of expertise need to produce the means for the remote sensing picture, to get a picture for remote sensing. So the task is using the instrument the detect, acquire, and calibrate the data. So the acquire data, calibrate them, and detect the object and phenomena on them. and for selected regions of the electromagnetic spectrum, and another term which would I share with you later on, being produced at the target. Transmitting data. It's transmitting data. It's all data which collect in a sensor needs to transmit to the Earth, to the user. So, and they need to be encoded on an electromagnetic carrier signal. So that's also the one part of the remote sensing. And this part which personal more interesting to me, it's analyzing and interpreting the data. Because you don't need to know everything before how the data no need precise information about the sensor or satellite or aircraft or helicopter drones, but you need to know how they work and how the electromagnetic spectrum help us to create the digital image. Because according to that, someone do the analyze and interpretation of the data on the images. And on the end, it's archiving and managing the data. You all say, I presume that's term big data, because it's a real term, because if you mean about Sentinel missions, they produce every day gigabytes and gigabytes of the information, and all that information need to be stored somewhere. So the archiving of the data, it's very, like I said, it's very important business, because when you're monitoring something, you can want to know how some surface looked like 20 years ago. It's from 1990, sorry. 1919, we don't have a satellite or the good picture. So if you want to go to the past and see how some surface, Earth surface is look like, you can also go to archive and find the satellite or aerial of whatever image about that surface and do the analyze according to nowadays data. So it's multidisciplinary. You can see from this information before that all these tasks essential for obtaining useful measurement with remote sensors cannot be performed by individual, but one man or only two men. You know, you need to electrician engineer, you know, aeronautical engineer, you or someone who want to produce or so sensors or images or deal with them need to have help from the experts from the variety of field, of variety of science fields. So remote sensing is accomplished through the team effort. So remote sensing, it's a team effort job, and needs to good collaboration of all these experts in the team. So close cooperation with different experts is needed, because if I want to help you or deal with some agrar surface or some forest surface, I need to know what someone or some forester or agricultural what they need to get from his props or for his surface. What are indicators to conclude what they conclude? So remote sensing is a service activity. So remote sensing isn't science which still alone what we do, just picturing at what we do with the images. So it is a toolbox for conducting Earth observation. So now we can say the Earth observation, it's gathering information about the planet's Earth and how they do that through the toolbox from known like remote sensing. So the objectives of remote sensing is tracking objects or phenomena on Earth's surface, or detection and extraction of objects like flood surface after flood, or defining the list of indicators for phenomena. Like I said, it's mandatory for good using of remote sensing methods for purpose. If you want to have the purpose of your analyze, you need to have the good list of indicators. That indicator experts define with the experts in some field, defined with the experts in the remote sensing, because experts in some fields know what they want to see on image, and the experts of remote sensing can they see or don't see that object or phenomena on image, and on that way they both do and define the list of indicators. And further objectives is to create a list of objects as indicators there, like I said, and the key of the efficient use of remote sensing is well define and articulate the needs. You can read the indicators for information need for decision making. So all of this, all methods of remote sensing or Earth observing cannot be done without electromagnetic spectrum. So what is the electromagnetic spectrum? So the most common remote sensing system measure reflected visible light, but they can also measure electromagnetic radiation that isn't visible to the human eye, like ultraviolet or infrared or microwave or some thermal part of the spectrum. So the electromagnetic spectrum, it's range from the shorter wavelengths to the longer wavelengths. So the shortest, it's gamma rays, and from the it's a cosmic range, so from the cosmos and from the space, and including microwaves it's a broadcast radio waves. It's the waves with a few hundred meters or bigger, because they can reach with her power more further than these shorter waves. So the ultraviolet part of the spectrum, so the effect that the satellite measure at different spectral wavelengths is used to obtain different information about the same object, features or properties being studied or analyzed. So, like I said, you don't need to be expert in electronics or in physics or it's space physics, but someone who wants to deal with remote sensing needs to know the electromagnetic spectrum in some details. No, but in more detail, but they need to know what it is, what the do with the collision with the parcels in the atmospheres or in the objects in the on the surface. So the electromagnetic spectrum we know better in next lecture, but now you will see the workflow of remote sensing techniques and how you get or how someone reach to the information and results of the remote sensing methods. So big picture shown its workflow. So for every picturing or take a picture, you need some energy, source of energy. So energy source of illumination. So you know when have a picture or you have be on tourist vacation or trip or travel, when you take a picture, you need some source of illumination. And if you outside, it's no inside or some buildings or whatever, that illumination are sun. It's mostly sun. So the first requirements for remote sensing to deal with these methods, so is to have the energy source which illuminates or provides electromagnetic energy to the target of interest. So suns, that's energy goes from the sun towards to the surface Earth. So that radiation of that energy go through through the vacuum from the space, and in the vacuum they have no obstacles in the vacuum. It's nothing are there. So when this energy enter in the atmosphere, so in the atmosphere are the small parcels of the dust, of the water, of the carbon dioxide or whatever. So as the energy travels from its source to the target, it will come into contact with the interact with the atmosphere when passes through. So this interaction takes place a second time as the energy travels from the target to the sensor. So you can see the two B's on this image. So one B it's from the travel of electromagnetic spectrum from the sun towards to the Earth surface, and after reflection, they go once more to the atmosphere when they go to the sensors. So after passes through the atmosphere 2 times, it's for satellite imagery. That energy make its way to the target through the atmosphere, and it interacts with the target depending on the properties of both the target and the radiation. So better it's to speak. So after passing through the atmosphere, they came to sensor and hit the sensor with the energy they collect when reflect from the Earth, and after that energy recording on the sensor, and in this time the image are created. I also tomorrow will explain how image is creating according to this energy. After creation of imaging, so can we this system deal with the transmission after the images are produced. That images need to be sent to the ground station, where that images got the physiognomy, like I said, they got the shape of images. And after that, after preprocessing, it's a geometrical and radiometric preprocessing to get the, like I said, a decent image, or image which someone can use. The images put in archive, and someone who bought, or if the images are for free, they can get that images, use and interpret and analyze them, and extracting to the objects or phenomena from that images, and gathering the information who need to get for some expert decision, for decision support in whatever field some experts need. And on the last one task in this workflow, so like I said, I want to said once more for remote sensing, you need or someone need a source of energy, of illumination. After that energy go through the atmosphere to the Earth. They reflect from the Earth and go once more through the atmosphere to the sensors. Sensors collect that energy and measure them, create the image. After images are created, they send to the Earth ground units, and after that there need to be preprocessing geometrically and radiometrically to get a shape of image. And finally, that images go to the application. The final element of the remote sensing process is achieved when to apply the information we have been able to extract from the imagery about the target in order to better understand it, reveal some new information, or assist in solving a particular problem. So if you deal with the images, aerial images from the aircrafts or helicopters, drones, the illumination or electromagnetic spectrum don't go to the atmosphere, to the whole atmosphere once more, then to go to some 10 meters or 100 meters or some thousands of meters from the ground, and in that manner the sensors can be different. They can be produced in a different manner, because the much more energy we have for drones or aerial images, because it's closer to the ground after reflection, than the satellite images, because satellites are flow around the Earth in orbits. It's from 300 to 800 kilometers. So that energy lost, the part of energy when go to the whole atmosphere. You can see, and we talk about in an other lecture, and see what cause that things. So this is the workflow of remote sensing tasks from the illumination source to the results from the images. So this image for the reflection, but the image can be gathered also from the emitted energy. It's thermal one, it's thermal image. They collect the thermal images. It's images can be produced in the night because all objects above the absolute zero emitted energy, and that energy used to create thermal images. So someone can get a thermal picture in a dark room, in the night in the dark room, because it's different physics behind that. You don't need to use the reflection, but emitted energy from the objects in environment. So now I would take a break, 15 minutes, and if all right with you, and sorry if you have some questions, I maybe can answer from some question because I don't have a chat. If you have some question, you can ask, but if you don't, we can, or no, not we can, we are further with this lecture in 3 o'clock.
Okay.